or a dashed box through it, that looks like it should be the parent. But when you have this molecule, it's just as good that this would be the parent, and that's a methyl group, versus that being the parent and that being the methyl. These two things in this molecule are identical. So that's a primary carbon, that's a primary carbon. Really, there's no difference between them.
Oh, okay. So there's no tertiary carbon?
Yeah, this carbon right here. This carbon has 3 other carbons on it. That's the tertiary carbon. That's the more likely one to get attacked. Oh, were you thinking that those methyl groups were the tertiary?
Yeah.
Yeah, no, it's that one that's attaching to 3 other carbons in the
Okay, I
tertiary.
got it. Thanks.
Yep. Everybody else okay, Denny?
Secondary would be like 2 carbons or something?
Yeah, this one right here is a secondary carbon because it's got that one and that one on it. Mm-hmm. So that's our substitution reaction. The next one is going to be an addition reaction. What do we start with in addition reaction? This is one of our questions on the reading quiz too. What's the organic reactant in an addition reaction?
Unsaturated.
It's got to be an unsaturated compound. Okay, let's see it. So we have to start with an alkene and then some other small molecule. It usually would be a halogen molecule like Cl2, Br2. Sometimes a water molecule, sometimes like HCl or HBr. A real small molecule plus the unsaturated. And so in an addition reaction, the unsaturated molecule becomes saturated. Remember, unsaturated means that you could react this thing and get more atoms on the molecule.
That was the one. The question was, what's the reaction when it goes from alkane to an alkane to an alkene? So this
Alkane to alkene is dehydrogenation.
Yeah, I got it.
This one is a halogenation, where we're adding the whole halogen molecule onto the organic part. We talked before about when you have a double bond, the first bond in a double bond is always the sigma bond. In the sigma bond, the electrons are always shared directly in between the 2 carbons. The other bond is the pi bond, and the pi bond, the electrons are shared above and below. Remember, you got those p orbitals that didn't hybridize. There they are. And so the electrons are being shared. Remember, electrons can't all be in the same place because they'd push away from each other. They don't like each other very much. They repel. So if you're going to share 4 sets or 2 sets of electrons, which is 4 electrons, they can't get in each other's way. So there's the sigma, and the pi is above and below. That pi bond is subject to getting attacked. And that's what is most likely when you have an unsaturated compound, the reactants are going to go looking for those pi electrons. So when you have an addition reaction like this, the sigma bond between those 2, that never gets touched. You got the sigma and the pi, and it ends still having that sigma bond there. So it's only the pi bond that gets attacked. And there's 2 electrons there that are represented by the red part. There's 2 chlorines that are going to go looking for something to attach to. So that pi bond breaks, this probably would be initiated by an ultraviolet wave too. You know, you hit that thing, the CLs break apart, they attack that pi bond, and each of the CLs is going to go and bond to the carbon atom. That's an addition reaction. Another just example of an addition reaction would be the same reactant here, ethene. It's got the double bond, reacting with a water molecule. Now the water molecule can split up into 2 parts. Even though there's 3 atoms, water does this very commonly. it'll break off one hydrogen, and then you'll have the OH over there. It's rare that water will break both hydrogens off of it and just have one O and two single H's. Usually you break off, you get one H and then an OH. So that's what happens there, is the H bonds to one carbon, the OH bonds to the other carbon. And what is the name of the product of this reaction?
Saturated.
What's that?
It's
Saturated.
It's saturated. What's the name of it? Could you name it? Yes, you're right about that. It's saturated. It's got an OH on it.
Oh, it's all ethanol.
What, Nathan?
Yeah.
Ethanol. Right, ethanol. That's one way that ethanol could be made. We make a lot of ethanol in the world. Do you think this is the most common way to make ethanol? You know, like cars are running on ethanol. They take a bunch of ethene and react it with water to make ethanol. No, this would work. You know how they do it? Not specifically, but generally how they make ethanol so much, like zillions of gallons every year. They normally, it's the degradation of biological stuff, like corn. I think corn is the main source. Did you know that, Carol? Yeah, it's corn. Soybeans, they use soybeans a lot too. And they put stuff in it like yeast that causes it to break down and ferment. That's how the drink alcohol, alcoholic drinks are made, is the fermentation of biological stuff. This is the only type of alcohol that our bodies can drink and metabolize and not be poisoned with. I've heard of people drinking, like going into their medicine cabinet and taking rubbing alcohol and drinking because it says alcohol, you know, trying to get drunk on that. Yeah, yeah, your body doesn't know what to do with it, and I'm sure it would make you throw up. But yeah, it is toxic. It's very, very dangerous to do that. Methanol, same thing. It's easy to get methanol. Don't drink methanol thinking that because it's an alcohol you can drink it. The only one that you can drink is ethanol. I don't want you to drink that one either. But yeah, never drink anything that's an alcohol other than ethanol. Okay. So let's do one where you'll try to complete an addition reaction. See if you can write what the products or the product of this addition reaction is. Got a product on there? Addition reaction? Okay, I'm going to put one of the possible products up. How about this? Is that possible?
Yes.
Did everybody have that when you filled it out and completed it? Some are saying no. If you said no, what did you have? How is yours different from mine?
Just switch the BR and the H.
Yeah, the H and the BR, that's from that HBr. If you switch them, that's possible too, right? Are those two products the same thing?
No, because they're different locations.
Right. They're isomers of each other. 2-bromopropane, 1-bromopropane. They're different. Unfortunately, there is one that is favored over the other one. We have to learn about that too. So we have to know what products are favored in a substitution reaction and what products are favored in addition reaction. I love this guy. There was a chemist from Russia who was dedicated. He dedicated years to organic reactions like this and determining favored products. His name was Vladimir Vasilyevich Markovnikov. What a name.
That's so funny.
Isn't that good?
So,
Vasilovich. I could never come up with a middle name that good. Markovnikov, he came up with, he did this reaction thousands of times. And he determined this, that when a small molecule is adding to an alkene, if there's a hydrogen, the hydrogen is more likely to go onto the carbon that started with more hydrogens. So the carbon that started with more hydrogens is likely to take the additional hydrogen.
also your first one.
What's that?
Your first one would be more favored because it had C.
Yes, that would be the favored product. Yep. Not that I didn't like yours.
Wait, which one's the second one?
The top one is the favored product. Because this carbon on the end started with more hydrogens. So that's the one that the hydrogen that's adding on is more likely to go on to.
Oh, I see.
But what about the CH3? If there's like more, wait, never mind.
Yeah, that one, that's not part of it because it doesn't have a pi bond on it. That's
Okay.
going to take. That's kind of immune from the addition part.
Oh, okay.
Now, people in chemistry know Markovnikov's rule as like an economic statement. This carbon that already has a lot of hydrogens gets another hydrogen. And think about Markovnikov. He was, from old Russia. Back in the 1870s, I believe, is when he did this work. A lot of poor people in Russia, very strong military-minded government. And then you got all these people who are, starving and trying to make ends meet. You get this rich government. Very dictatorial kind of society. So it's I wouldn't say it's a joke, but it's well accepted that this really is what Markovnikov was saying. The rich are just getting richer. The carbon that already has a lot of hydrogens, it's just going to get more. Right? It's that oppressive kind of government mindset. The book talks about Markovnikov, not in the text part of chapter 22. They actually cover it in one of the exercises, and I don't remember if it was assigned or not. But you'll come across it. You'll know when you see it because it's a problem that takes about that much of the space in the, every problem, they only need about that much space, but you got this whole explanation of Markovnikov's rule in the problem. And we're gonna crack up together about some of the problems that the Zumdals come up with because they'll give you like a whole biography on a particular molecule and then they'll ask the question about it. It's like, why did you write a paragraph about it? You could just ask the question and we could be done with it now. It is kind of funny the way they do. We'll see that. Not so much in this, but like when we go to the stoichiometry chapter and after that, it is funny. They're smart people. All right. So yeah, there's our main. Oh, I have a picture of Markovnikov too. There he is. Look at that. If you look at him and I ask, what nationality you think he is? You see that beard? Oh yeah, he's Russian. Yeah. And again, that doesn't mean that some of the molecules don't have the Br over there where the it could be that there are a number of molecules that wind up that have the Br on the end carbon. But the major product is the one where the hydrogen that's added goes onto the carbon that already started with more. Okay? That's the addition reaction. This was in the reading assignment. Now, where I went from here, we talked the day before about alcohols, ketones, and aldehydes. So we covered those two. And how are we doing for time? I have one other type of reaction that I'd like to go through with you. I don't think that anybody in here studied oxidation reduction in Chem 1. Does oxidation reduction chemistry ring a bell to anybody? Redox? Who did you have for Chem 1, Claire? I didn't remember if anybody... I know I didn't. If you had me, a couple of you had me for Chem 1. We didn't do it last year. We didn't even get through acids and bases, which was a shame. We'll spend a lot of time on acids and bases in this class. Why are you looking at me like that?